Hello and welcome to this video where we'll go into LanceDB, the fundamentals of it. LanceDB is an open source vector database designed to handle large-scale vector data efficiently. It provides a robust platform for storing, indexing, and querying high-dimensional vectors, which is very good for working with, for example, LLMs and RAG applications. RAGs are Retrieval Augmented Generation. Whenever you want to chat with your data or chat with your documentation, you're providing a query, a prompt or a query, a text, which is then transformed into vectors. And this vector is compared to all the other chunks or all the other documents in your database. And you find the one that is closest to it semantically based on vector search. And in LanceDB, we will also go into both vector search, full text search, and also hybrid search, that you can combine both full text and vector search to make it very powerful. But before that, we will go into just working with LanceDB and getting started with LanceDB to navigate around it. How does it work with creating a table? How are the tables stored? How can we add data? How can we create schema, etc.? And what are the formats of the data? These are some fundamental things that you should know about LanceDB before you jump into RAG applications. In many other tutorials I see when it comes to LLM and RAGs and agents, they jump directly into a proof of concept without covering the basic knowledge of all the other components. Here I want to cover the fundamentals of LanceDB before we jump into RAG applications, which will come in later videos. Let's get into Visual Studio Code now directly. Here I am in Visual Studio Code, and you can see there's two data I have here, or two JSON files. Here I have animals text.embeddings.json. And here, this is basically JSON data, and you can see there's text and there's vector. And here I have jokes.json, where I only have the text. These I will come back to later on, and I will just say that these are available in my repository, which I link in the description. And this is what I use for, I have taken this from ChatGPT to generate this. Generate this fake data that I can use this as examples. Let us start with a terminal now, and I will do touch LanceDB basics.ipnb. I will create this LanceDB Jupyter notebook that I will use, and I will start with creating a virtual environment, UV init. And here I initialize an environment. I'll do rmain.py since I don't need that one. And then I'll do UV add ipy kernel. And what do I need? LanceDB. And if I need something else, I will install it on the way. Let's move on to LanceDB, a vector database. Yeah, for LLM applications. That is fine. I'll change my environment to this LanceDB demo. And here I will change to Python. Import LanceDB. I will increase this one. Import LanceDB. And then I will do db equals to LanceDB.connect. And what do I want to connect? I want to connect to my vector database. I will do URI. This is the path where I will put the string or path and the URI of the database. What do I want to connect on? I want to connect to something called vector_database. I call this vector database DB. You can see it is basically, first time it takes a little bit of time because of some caching, but now it's done. You can see this is the wrapper, LanceDB connection, URI equals to this path into this vector database. You can see this vector database here. It's an empty folder. Yes, that is expected. I will show you a little bit how to work with this one. Save this one and then do db.uri. And you can see this is the URI. Yes, that is what we expected. Let's start with creating a table, basically. I'll move this down and I will do like this. Create a table. Now we have our DB, right? DB is connecting to this folder here where our LanceDB should be. DB, you can see this is the LanceDB connection. Let us create a table. And before we create the table, we'll import some data. Import JSON, and we'll do with open. I will do data / animals. Let's see, animals underscore. Let's go see here, animals underscore text embeddings.json. Remember that embeddings means that it's basically just the vector representation of the text. The text of each, that's why we have like text here and the vector, text, vector. Now we have vectors in 3 dimensions, but it could as easily be 3,000 dimensions, for example, or 4,000, depending on which embeddings model you use. Data / animals text embeddings.json, and then I want to have the mode of read as file. I'm opening this file here. And what do I want to do? Data equals to json.loads and file.read, basically. And then I can take a look into data. I can see it's a dictionary here, or it's a list of dictionary. And as a list of dictionary, we can just put it into our table directly, or we can create a table and put it inside. Table animals equals to db.create table animals underscore text. I'll call it that. And we'll do exist equals true. This makes it idempotent. If I run it several times, we will get the same results, because if it already exists, it won't create another table. Instead, it will just create a table if it doesn't exist. This is what I loaded in. Table animals looks like this now. This is the wrapper for table animals. Lance table, name animals text version 1. Take a look into the vector database now. We can see there's a few things here. If I go into cd or I can actually do 3 vector database, and you can see the vector database looks like this. We have animals text.lance. This is quite interesting. All the tables will have this suffix .lance. And inside of each tables, we have underscore transactions, we have underscore versions, and we have the data. The data is also, it's a .lance file. And here versions is a 1.manifest. And here transactions is 0. This is a transaction. It's just a transaction. Whenever you're adding more data, you will get more transactions. You will get a newer version, etc. Let's try to do that. If we run this again, you can see that if I run this one again, we can see nothing has happened, because it didn't do anything when I did exist. If I copy this one, and instead of exist, and I'll run this one, and you can see there is an error, a value error. The value error is that table animals text already exists. We cannot create it again. And also you can change something called mode equals to overwrite. If I do this one, now you can see it's in version 2. And if I run this again, you can see there's transaction 0, 1, 2, and we have 2 Lance files here. Basically, we have all the history stored inside of this animals Lance table. Basically, here you can see there are transactions and versions and data. All these are stored. The history is stored. That is very good to know. Overwrite basically is just I'm overwriting the old data. Basically, if you take a look into table animals now, .head to see the data, I will remove the terminal. And you can see this is same as I'll show you the whole data to see that we don't have duplicates. But here is the PyArrow table. PyArrow, it's a file format, which have some metadata and it has some data. And this is stored in a very memory efficient way. And it's very fast to work with. You should know that the PyArrow table is the underlying file format for storing the data in LanceDB. I will make videos about how to work with PyArrow in the future, but if you're not familiar with PyArrow, that is fine. Just know that this is the underlying format, and we will work with it as well. That it's good to know. I will make a video about that in the future. We can also do something like this, tableanimals.pandas, that you can see a module not found. Then we need to install pandas. I have added pandas and run this again. And now it should work. Yes, it takes a little bit time first time. And as you can see, there isn't copies of the data because basically I overwrote them before. We have 6 data points, which we had here as well. We had 6. It looks like this. We have text and we have vector. This is a normal pandas data frame that you can work with. You can filter it. You can do whatever you want with it as you could have done in pandas. I assume that you already know pandas. If you don't know, I have a lot of videos about pandas. You can take a look into that. Let us create some more data to see what will happen. More data equals to, here I will just copy from my notes. You can also take from my notes since I don't want to type it out. Here we can do tableanimals.add more data. And you can see add result version equals 3. Let's see what will happen now. I'll take out my terminal and I will clear it, Command K, and then I will do tree again, tree vector database. You can see there are 3 now, 3 versions, many free.manifest. We have data, we have free Lance data. And here we have transactions, we have come to 2 here. And you can take a look into this one, it reflects here. Now we can take a look into tableanimals.toPandas. And here you can see, there are 8 points now. We had 6 points before, right? Now we have 8 points, or I will call it rows, basically. I'm talking about points when it comes to vectors, but basically it's rows here. We're storing text and vector. It is quite suitable if you have some kind of vector representation already with your text, right? But later on, we'll show you that it's maybe more practical that you just put in the text because you may not have the vector representation of it. I'll show you how to generate vector embeddings based on just text. But first, we should go into some more operations. We'll try to create an empty table and then delete it, because I believe it's very important that you understand the tool before you actually go into. You need to understand how to work with LanceDB, that you're comfortable with it and not just to be able to copy and paste some tutorial and think like it works, but then you don't know how to apply it to your own project. To create an empty table, you cannot just create a table that is empty, because an empty table do need to have at least a schema. Either you put in some data or you put in some schema. And the schema can be defined in 2 different ways. One way is to use PyArrow schema, but I don't assume that PyArrow. I will use the other way, which is to use a Lance model. And a Lance model is basically a Pydantic model. Since I have done some videos on Pydantic before, then you should know what Pydantic model is. This depends on a Pydantic model. What we should do is from LanceDB.Pydantic import Lance model. What is a Lance model? A Lance model, I take a look into here. It's a Pydantic model base class that can be constructed to a LanceDB table. That is very important. It's not just a Pydantic model. It's a Pydantic model that can be converted to a LanceDB table. Then we do like this. I will create a joke schema. And my joke schema will have Lance. It inherits from Lance model. And since it's inheriting from Lance model and it's a Pydantic model, right? And you know how to create a Pydantic model. Basically, you have fields and you have type hints, right? We'll do joke, it's a string, and we'll do rating, it's an int. This is our joke schema. Then we can do db.createTable name equals to jokes. This is the jokes table. Schema equals to joke schema. And we can do exist equals to true. It becomes idempotent. You can see the DB. It's still the LanceDB connection. And you can see something happened to the left. You can take a look into vector database. We have animals text.lance, but we also have jokes.lance. And here we don't have data, but they have transactions and they have versions. We cannot take a look into these, but the thing is now the schema is stored there. Whenever you add data, you need to follow this existing schema. But I won't do that. Instead, I will do DB table. I showed you before how to add data. You know how to do that. Table names. We take a look. We have animals, text, and jokes. Then we can do db.drop table jokes. We drop this table, and we can see db.table names. Now we only have it's a method. We need to have callable. We have only animals text now. Great. Now I have created a table, and we have deleted a table. If you already have some tables, you may want to open a table, open existing table. And to do that, we do db.open_table, and we can do like animals. Just take a look that now we only have the animals, right? If you only have one folder, VS Code collapses it this way. If you have one folder inside another folder. Yes, and now we can just open this table, animals_text. And you can see we have opened this one, and I can do .head. And you can see we're in version 3 as we saw before. But here, .head, you can see there's 5 data points in .head that we can take a look into 2 data points if we wanted to. Here, a small brown dog running, a cat resting quietly on a sofa. Cool, cool. Now we come to very cool thing. Vector search in LanceDB. Vector search in LanceDB, it works in a way that it uses approximate nearest neighbors for searching for vectors. We can search with vector directly if we have the vector embedding, which you can do. You can use embeddings model to embed your text, and then you can search with it. Or you can just send in text, and then it will generate an embedding for you, and it will find the closest matches. That is even cooler, but we will start with the first approach. Just take a look into table animals.head. I will .to pandas. Now you can see this is all the data that we have. We have 8 points here. And let's do here. Let's create a query vector, just something I can fill. Query vector equals to 0.5, 0.2, 0.9. If you take a look into this, you should maybe be able to find the closest distance. I can see like maybe a panda eating bamboo peacefully. Here you have 0.51, 0.37, 0.82. Yeah, could be this one, I think. Yeah, if I just eyeball this, I think it's this one. That should be the closest one. Take a look into now table animals.search. We'll put in our query vector. Basically, the idea is that later on is that someone put in a query searching for something, and then it will be transformed into a vector, and the corresponding vector is used for the searching. Here we have search for this query vector, and we can say .limit top 3 results to pandas. And we can take a look. Yeah, a panda eating bamboo peacefully was the one that was closest, as we saw. And it calculates the distance from it, and this is the Euclidean distance. According to the documentation, I have actually not just computed it and double-checked, but probably it's true. This is the distance from this vector to all other vectors, and then it's sorted in ascending order, the minimum distance first, right? Now let's use Embedding API. The idea now is that we want to put in text, and it will auto-magically generate vector embeddings, then another idea is that we put in a query and it will auto-magically generate vector embeddings. And then it will calculate closest distances. That is the idea with this. The Embedding API, there are several ways to do this, but in the documentation, you will see that you can register different APIs. We'll show you from LanceDB dot Pydantic import Lance model. Actually, I already done that, but I didn't need to do it again, but just to show you here. And vector, I need these two from Pydantic. These are different fields from Pydantic to use. From LanceDB dot embeddings, I want to import get registry. Model equals to get registry dot get. Here I use Gemini. I took a look into documentation and it's called gemini-text dot create, and the name equals to whichever model you're using from Gemini. I use embedding-001. And now you can take a look into model. It looks like this. This one, getRegistry.getGemini-text.create, it basically creates an instance of this Gemini text. You have Gemini text here. You can see max retries 7, model, name Gemini embedding-001, etc. With this model, you can do like this. You can do model dot generate embeddings, for example. And you can say hello. Please install Google-generative AI. Let's do that. UV add Google-generative AI. Yes, I did that. And now this should work. I could not find API key for Google. Yeah, then you need to create a .env, and you need to do Google_API_key equals, and you put in your API key. If you don't know how to find the API key for Google Gemini, take a look into my previous video where I have done that. And when in my Gemini video, I show you how to do that. I will just paste in my API key. I did that and it worked. So now I also restarted and ran the whole notebook again. You can see now it says model.generate embeddings hello, and it works. I got some embeddings. Let's just call this hello embedding, for example. And I will also do like this, import numpy as np. I got numpy from when I installed pandas, np.array, because I want to take a look into this shape here. Then I will do hello embedding dot shape. And you can see it says 5,3072. We know that the dimension is 3072, but you may see in the documentation something similar to, I will show you here. I will create, and now I will create a joke model class. This is the new joke model or joke schema, joke model. It's inheriting from Lance model. And I will use joke. It's a string and model.source field. What is this? It marks a text as input to embedding function, which means that if you just put in text and you have this as well, you have vector of 3072 equals to model.vector field. What it does here is that the vector is the destination of the computed embedding. The text which you put into source field, it will automatically generate a vector embedding. The vector embedding is created automatically if you just input a joke and you don't put in a vector, but if you put in a vector, then it will use that input instead. If you just put in a lot of joke text, then it will automatically create a lot of vector embeddings for you. That is quite cool. And also whenever you put in a query vector, it will also automatically create an embedding for you based on this model, right? This is the embedding function which you defined before. It's this embedding function that we used. And one more thing is that in the documentation, you would see something, this model endings. However, if you note our model.endings, if I just put it here, this method, you can see 768. It's not corresponding to the actual shape. The actual size is 3072. It's many dimensions that we have. This is probably like it's still something that is pointing towards an old documentation, an old model that it has 768, while the newer one has 3072. Maybe they haven't changed it. What you should do here is instead to either just put it in hard-coded like this, or you could just take out an example embedding and then take the shape and you would get the same results. But I will hard-code it, it doesn't matter. I have this joke model now. And what I should do is that I will do table underscore jokes. I'll create a new joke. You can see now I only have the animals table. I will create a new jokes table, db.create table, and I will call this jokes. And I will do schema is the joke model. This is my pedantic schema, which is able to convert into a table, right? Remember I said that about the Lance model. Very idempotent. Table jokes, as you can see, now we have connected to this LanceDB demo vector database. If you take a look into vector database, now we have jokes.lance as well. And here we have transactions and versions. We haven't put in any data yet, right? Let's add some data. I will do, for example, we tried to add the JSON data before and it worked, a list of dictionaries, but now I will send in a pandas data frame to see that it's also working. With open, let's see, data/jokes.json, read as file, and then I will do jokes data equals to json.loads file.read. And then we have jokes data that looks like this. So we have a dictionary here. Then we could basically just put it into a pandas data frame, probably. pd.dataframe, jokes data like this. Yes, perfect. Now you can see there's a lot of rows with, and actually one more thing is that you see it's called jokes, while I've used joke in my Lance model. What we need to do is that we need to rename it. Rename, let's see, jokes into joke, and then axis equals 1. Perfect. And you can see each joke is only the text. We don't have any vectors, and that is totally fine. That is the idea here. df jokes equals to this one, df jokes.head. We don't need to show everything. And if you, for example, take df jokes of 0, and then you will get, or .iloc, and .iloc 0, and you can see here we get the full text. It's actually quite fun. Parallel lines have so much in common. It's sad that they will never meet. Yes, that is really a good joke, actually. Side note on that. Let's now add our data to our table. Add data to table. We can do it simply by, we have the table jokes, right? This is our table. If it's take of head, it's empty right now. We can do table jokes dot add, and we can take df jokes here, and you can see we have added a lot of data. It takes a little bit of time, but it shouldn't be that long. Yeah, exactly. Now we have it. We have table jokes dot head, and now you can see, oh, cool. We have data, and we have the vector embeddings as well. Note that the vector embeddings were created automatically with the model embeddings. So we have the embedding model, which we had in our text model. If we go up a little bit here, We just put in the text, right? We just found this joke column. We saw that it didn't have a vector column. What it did was it calculates this using the model's vector embeddings and calculates out the vector embeddings. We have vector embeddings for each of these. And I don't want to show all of them. I'll take 2. And I can do like this, table jokes to pandas, so that you can see it. And we have a lot of jokes here. We have 29 of them. And we can take out a vector. And you can see the shape here is 3072, which is the shape that we expected. That is really cool. Now it's time for us to do some searching. To do some searching, it's really easy. It's table jokes.search. Data engineering jokes, for example, limit 8 2 pandas, 8 closest ones. Yes, perfect. And you can see we have why do data engineers hate nature, data engineers motto, what do you call a snake that runs your script, blah, blah, blah. At least you can see the top here ones are related to data engineers. Cool. And we can do similar thing here, copy this one, paste it here. I will change a little bit. Give me some jokes on C#. And you can see, yeah, there's some with C# related, and then the Python programmer. Probably is that, why did the Python programmer get bitten? Because he cannot C# or something. Not sure. Let's see. We can continue here and give me chemistry related jokes. I know I had some chemistry jokes there. Yeah, and then we get a few chemistry jokes. Copy this one. Remove Pythons like this. We'll have like nature related jokes. Yeah, then we got a few nature related jokes. And these were vector search. We're searching based on the closest vector distance from the search vector. This is the query vector, or this is the query, and it will compute the query vector, and then it will use the query vector and compare to all these vectors that exist in our database table, and it will calculate the distances, and you can see the closest distance are those that are first. This is sorting in descending order. Let's go into hybrid search. Hybrid search basically combines traditional keyword-based search with vector similarity search. Keyword-based search is using something called BM25, which has been used a lot in search engines for ages. Vector search is more recent for when we want to do searching with natural language. If you're searching for more exact keywords, then it's better to use traditional keyword-based search. And if you want to search with similarities and you have changed the meaning and more natural language search, then vector is better. However, hybrids is a combination of these two. And how should you do when you're doing search? Should you do just full text search or keyword-based search or vector search or hybrid search? It depends a lot on your data sets. There are a few rule of thumb. But basically, it's more of a trial and error. You try and see that, is this reasonable? Is this results reasonable, etc. I'll continue here. In order to enable keyword-based search, we need to create an index, not on the text column, but on the joke column. From, let's see, we can do table jokes dot create FTS is full text search index on joke column, and here I will do replace equals true. If you're choosing another one, if you do it again, it will replace the index. And now I will do from LanceDB import re-rankers, and re-rankers, what it does is that it will re-rank the result from a vector and a full text search. It re-ranks it based on a certain algorithm. And there are different types of re-rankers that can be chosen. For example, linear combination. And the one that I will use here is RRF re-ranker. And this is the default one. We'll use this one. Re-ranker equals to re-rankers.rrf re-ranker. It will re-rank it based on a certain algorithm. And also, which re-ranker you should use is also a hyperparameter that you should tune. You're testing out different re-rankers for your particular data set and see what will give most consistent and best results according to your own metrics. AI engineering is actually a lot of engineering, believe it or not. Results equals to table jokes.search. Give me nature-related jokes. I use the same query as before to show that we can do a hybrid search instead and see if the results differ. Vector column name, it's the vector that is our vector column, and then FTS column, we have created a FTS column, right? This is the full text search column, and this is the vector column. You need to combine both, right, in the hybrid. And when you do that, you do a re-rank. You put in your re-ranker equals to re-ranker. Dot limit, I'll do limit 8. We can see same as before, and then 2 pandas. And then we have results here. The first one was the same. Why do data engineers hate nature? And here you have a relevance score. Let me just see if there's something differing. Second one, gold walks into a bar. 3, why did the chemist ground his kids? I told a chemistry joke. Yeah, gold walks into the bar is the third one. It's, it became a little bit different. This one was more, let me see, gold walks into a bar. Yeah, that was the second one. And now the second one is I told a chemistry joke. This had higher relevance according to the hybrid search. That was quite cool. It's a little bit different. And as I said, you need to try it out on your data set, but there are a few rule of thumbs. Let me change this to Markdown. Markdown. Some rule of thumb is that we have for exact matching, then we use FTS, full text search. Meaning-based matching, then you use vector search, and both or unpredictable or mixed queries, you use hybrid search. These are few rule of thumbs. The best is to test out which works, try different hyperparameters to get the results that you want. A lot in AI engineering to get more consistent results. A lot of engineering. You need to know how to evaluate the results, what to evaluate on, what are good results according to your own metrics and your requirements. Now, one thing that what need to be done is that if you're working in Git and GitHub repository is that you should commit and push. But before that, we don't want to push the vector database. I will basically just go into my git ignore. Yeah, I should have a git ignore. Very important, we should have a Python git ignore, but since I don't have it, I will have .env here. Save this one to remove my .env because I have my secrets there. I will have a vector database I will also remove. I don't want the vector database to come up, and the rest I can commit and push to my GitHub repository. In this video, we have gone through LanceDB from the basics and up to different search with vector search, full text search, and hybrid search. In the beginning, we worked with different operations such as creating table, adding data, creating schema using Lance model, took a look into embeddings, how that worked, and vector search with own vectors, and then vector search with own text. I hope that gradually you started with very basic understanding of LanceDB, but then moving on to the key points of LanceDB, that is to utilize its vector capabilities and working with the different vector search to find the closest matching text to your query, which is very useful for applications such as RAGs, Retrieval Augmented Generations, where you can chat with your own data and your own documentation. That is really cool, and I hope that I will see you in the next video where we'll continue building upon these topics and building up RAG systems. Thank you for watching this video. See you in the next one. Bye.